So this is, you could look at the bars in behind, right? This is supposed to be telling us the percent of babies that are born to full term, right? They get all the way to the end of the 9 months based on their weights, and the weights are in grams. So, you know, this bar right here is for babies that were between 3,000 and 3,500 grams. That's the one that had the most. When the babies weighed more than that, then you had less reporting of that, right? And if they weighed less than that, again, it falls away to the other side. Now, the red line behind that is actually the normal curve, right? That is a function which gives us this shape, and that shape is often referred to as a bell curve, right? That is a bell curve. So this, do I have this on the pen? Right. That shape is the normal curve, or the bell curve, because supposedly it looks like a bell. Right? Now, there's a really famous book that's called The Bell Curve from the early 90s, which is very controversial, and I had it over there on that shelf, and it's not there anymore. So I got some kids that borrow books, and I never bring them back. And I never know who, but it's a very controversial book because of the way it deals with IQ, and it treats IQ as a normal distribution kind of thing, the result of random processes. And a lot of people are offended by the use of IQ to make correlations and inferences about other characteristics and things like that. Now, the one thing you note about the bell curve or the normal curve is, you know, it's smooth. The bell curve goes up smoothly, it reaches a peak, and it goes down smoothly like that. The bars behind, they're not smooth, right? They're rectangles. You know, there's part of this rectangle which is not under the curve, and then there's a space here that's not included by a rectangle, but it's under the bell curve. You know, you're going to get answers when you answer with the actual data that are always whole numbers of data. When you answer with numbers that come from the function, which is the bell curve, you're going to get decimals and all kinds of fractions and things like that. That's expected. Oh, one thing to point out on this here is this bell curve, as it falls away here, is approaching the bottom axis, we'd call it the x-axis, like an asymptote, right? It never touches the bottom, right? There's always a little bit of space in between that line and the x-axis, right? And the total area, if I added up the area under the curve, right, this is not a shape like a circle or a triangle or anything like that we have a formula for. But if you added up the area under the curve, 1. Perfectly 1. Always. The area under a bell curve is 1. Okay, let's see.